Welcome to Part 6, Section 1 of the OwlBot project. I know what you're thinking. Why are we going to draw our schematic diagrams by hand? Can't we just use some type of software that will allow us to quickly draw up whatever we need? The answer to this is yes, probably. But there are a couple of reasons why I like to draw my PCB schematic diagrams by hand. One, it helps out to create a visual aid. When drawing a schematic diagram by hand, I can draw it to the best of my ability as the circuit should look in the real world. This helps me to visualize how components should connect to the PCB and to determine exactly where they can go. Two, it makes customization easy. With a hand-drawn schematic diagram, I can lay out how I want the components to be down to the exact through holes on the prototype PCB board. This allows for total customization for the specific board that is being used. 3. It removes any doubt during the soldering phase. Once I have my drawing all laid out and I'm ready to begin soldering components to the PCB board, I can do so with more confidence knowing that I have my hand-drawn schematic diagram I drew up beforehand. This helps remove any doubts that could have occurred if I had not taken the extra step of creating a visual aid. This is not a professionally done project by any means. If it were, of course, I'd want professionally done diagrams and schematics. We're just having fun here, but we also don't want to have a bad day by messing up our project by making the wrong solder connections either. Drawing out any visual guides can help out tremendously, especially one such as this OwlBot project since it has several components to deal with. If you're not up to drawing your own schematic diagram, you're more than welcome using the one that I provided down in the link below. Just know that it's customized to the type of boards that I'm using. So if you're using a different version of Arduino microcontroller, then your PCB prototype shield will obviously be different than mine. If you're using a different size PCB prototype board, my drawing won't be like how the placement of components will be for your type of board. If you decide to draw your own schematic diagram, don't fret on perfection. The sole purpose of the drawing is to act as a guide to solder your components in the proper way they need to be so that you're not second-guessing yourself during the transfer of components from the breadboard to the prototype PCB board. I like to draw components and devices used in my projects as they are. I may use schematic symbols if I think it'll work for my understanding of the circuit, but having a real representation of something makes assembly and soldering much more easier and comfortable for me. You can do whatever works for you. Just take your time and know that the most important thing is to make sure that you have all your connections correct. Use the help of the other schematics we used throughout this entire project series, and just worry about making your drawings practical, not pretty. I'll be sure to leave the links down in the description below for all the schematics that we used thus far in this entire project series. I've divided the placement of components onto two separate prototype boards. One is an Arduino shield board, and the second one is a 240-hole PCB prototype board. It's a 3 by 7 centimeter, I believe. I'm currently drawing that one right now. We will fit the Arduino shield board on top of the Arduino Uno that we're using for this project. It will give us a direct connection to all the pins of the Arduino. We will place the MP3 player we added in part 2 of the series directly to this shield. We will add connectors to the shield for access to the 5-volt supply from the Arduino, and we will add connectors to make a common ground, and we will make our connections for the speakers, the peer sensor, and LEDs for the OwlBot to this shield board as well. As for the 240-hole PCB prototype board, we will make our connections for the DC motor and solenoids we're using for this project, and we will also make direct connections to the secondary 9-volt power supply we added in part 4 of the series, consisting of 6 AA batteries. We will also make a connection from this board to the common ground that we'll place on the Arduino shield board. Okay, now that we have the hand-drawn schematic diagram out of the way, the first thing we'll need to do is to add the components we need to go onto the Arduino Uno prototype shield board and solder them in place. We'll reference the hand-drawn schematic diagram we created earlier so that we can methodically transfer each individual component one at a time from the breadboard to the shield board to be soldered. We'll start off with making the connections from the ground and 5-volt holes or through holes of the Arduino Uno prototype shield board. These connections will provide our common ground and plus 5-volt supply from the Arduino's onboard voltage regulator that will power components like the peer sensor, red LEDs, and MP3 player. First, we're going to take a couple of small lengths of black 22 gauge or 22 AWG solid core wire. We'll strip their ends about 1/4 inch and then bend both ends of those wires to be able to fit across the through holes that we're using to create the connections that we need. So I'm currently customizing a strip of black wire to extend from the ground through hole on column 18, the one next to the plus 5-volt supply, to a through hole on column 15 that's in line with that ground. And then I'll eventually take my second length of black wire to connect to the second ground through hole, because there's 2 locations for ground, not only from the Arduino itself, but on this Arduino prototype shield board, because it matches with the Arduino that it will sit on top of. The holes will match up. So for the second wire, I'm going to extend from the second ground through hole on column 18 to a through hole at column 16 that's in line with that ground. So as you saw earlier, I had already taken a small length of red 22 gauge or 22 AWG solid core wire. I had stripped its ends about 1/4 inch and bent both of the ends of the wire to fit from the hole at column 18 or the through hole at the plus 5-volt supply to the hole at column 16, which is in line with that plus 5-volt supply. And that's what I was showing with the arrow and the hand-drawn schematic diagram insert on the screen. Now that we got the first couple of connections made to the prototype PCB shield board, let's move on to the MP3 player. Looking at the hand-drawn schematic diagram, we can see that the chosen pin location on the shield board is located along columns 5 and 13. The DF Player Pro Mini MP3 player, written as its model number DFR0768, has a total of 12 pins, 6 pins on each side. I'm going to place the R-, R+, L-, and L+ pins on the MP3 player in line with the holes for pins 13, ground, AREF, and SDA respectively, along column 5 of the board. The pins for VN, ground, RX, TX, DACR, and DACL of the MP3 player are placed along column 13. When the MP3 is ready and positioned on the board, we can solder all the pins in place. Once we have the MP3 player soldered to the Arduino prototype shield board, we now need to extend the connections we made for the positive and negative supply jumper wires we did in step 1. First, take a length of red 22 gauge solid core wire, strip its ends about 1/4 inch, and bend both ends of the wire to fit from the through hole on column 16 in line with the row for the positive 3.3 volt supply. next to the small length of red wire we added earlier for the positive 5-volt supply. As you can see here in the video, I did not place this new red jumper wire in the location I just mentioned. Here in just a sec in the video, I'll show with an arrow where I ended up changing the location of the red wire I just mentioned previously. Solder this wire so that it's connected to the red wire we added earlier for the positive 5-volt supply. Next, solder the other end of this new red jumper wire in the through hole in line with the VN pin of the MP3 player on column 16. Now take a length of black 22 gauge solid core wire, strip its ends about 1/4 inch, and bend both ends of the wire to fit from the through hole on column 15 in line with the row for the positive 5-volt supply, next to the small length of black wire we added earlier for the ground. Solder this wire so that it's connected to the black wire we added earlier for the ground. Next, solder the other end of this new black jumper wire in the through hole in line with the ground pin of the MP3 player on column 15. Here, I'm doing all the soldering at once I'm done placing all the jumper wires in their through holes, instead of doing it step by step as I go. Looking at a close-up of the board as it is so far, we can see that on our Arduino prototype shield board that we have our red jumper wire coming from the positive 5-volt supply up and over towards the VN pin of the MP3 player. Of course, all of the soldering is done on the opposite side of the board, which we can't see at the moment. But we'll see what it looks like in just a second once I flip the board over so we can see that view. Here I'm pointing out the pin locations on the back side of the board where we need to solder the red jumper wires together to complete the circuit all the way from the positive 5-volt supply to the VN pin of the MP3 player. And of course we'll want to do the same for all the black ground wires that we created earlier. So we'll want to connect both of the smaller black jumper wires that we created coming from the two ground through holes, then soldering those two together to the longer black jumper wire that we created to extend all the way to the ground pin of the MP3 player, so that we can complete the ground circuit from the two ground points all the way to that ground pin of the MP3 player. Next, we need to add the two 680 ohm current limiting resistors for the two red LEDs we're using as the OwlBot's blinking red eyes we added in part 3 of this project series. You can see here on the hand-drawn schematic diagram where we'll be placing those two 680 ohm resistors. The labeled points A and B represent the connection points for the anodes of the LEDs that will connect via a JST connector we'll assemble later. What we'll end up doing is take one of the 680 ohm resistors and place one of its leads into the through hole on the prototype shield board in line with where pin 4 will be on the Arduino on column 3 of the shield board. Then we'll place the other terminal of the resistor into a through hole also in line with where pin 4 will be on the Arduino on column 7 of the shield board, as we saw earlier on the hand-drawn schematic diagram. Then what we'll do is take the other 680 ohm resistor and place one of its leads into the through hole on the prototype shield board in line with where pin 5 will be on the Arduino on column 3 of the shield board. Then we'll place the other terminal of this resistor into a through hole also in line with where pin 5 will be on the Arduino on column 7 of the shield board. Next, we'll end up taking the 1000 ohm resistor and place one of its leads into the through hole on the prototype shield board in line with where pin 2 will be on the Arduino on column 3 of the shield board. We'll place the other terminal of this 1K ohm resistor into a through hole also in line with where pin 2 will be on the Arduino on column 7 of the shield board. Then we'll solder each of the terminals of this 1K ohm resistor under the bottom side of the prototype shield board and trim the excess leads off with our cutters, just as we did with the two 680 ohm resistors. If at any point that you feel confused, you may refer to the hand-drawn schematic diagram that I drew that I'll leave down in the description below, and you can also refer to the step-by-step process of this part of the project via the link that I'll leave down in the description below. Once we have the resistors in place from step 4, we're now ready to make the connections we need to the RX and TX pins of the MP3 player using some more jumper wires. First, take a length of blue 22 gauge solid core wire, strip its ends about 1/4 inch and bend both ends of the wires to fit from the through hole on column 8 next to the lead of the 1K ohm resistor we soldered on column 7. Now take the other end of the blue jumper wire and place it in the through hole on the prototype shield board on column 13 in line with the 1K ohm resistor. Next, take another length of blue 22 gauge solid core wire, strip its ends about 1/4 inch, and bend both ends of the wire to fit from the through hole on column 13 next to the lead of the blue wire we just added. We're going to eventually solder the leads of these two blue wires together so that we may continue this blue wire path. Then take the other end of the blue jumper wire and place it in the through hole on the prototype shield board on column 14 next to the RX pin of the MP3 player module. So as we can see here, our path should follow through from next to where pin 2 will be on the Arduino, through the 1K ohm resistor and through the blue jumper wires we just added onto the board to the RX pin of the MP3 player. And looking at our diagram, we can see that connection from pin 2 through the 1K ohm resistor and over to the RX pin of the MP3 player. Now take a length of orange 22 gauge solid core wire, strip its ends about 1/4 inch, and bend both ends of the wire to fit from the through hole on column 3 next to where pin 3 will be from the Arduino. Now take the other end of the orange jumper wire and place it in the through hole on the prototype shield board on column 14 next to the TX pin of the MP3 player module. Referring back to the hand-drawn diagram, we can review that we've currently placed the positive 5-volt supply from the shield board to the VN pin of the MP3 player. We've also connected the two ground point locations on the shield board to a single point on the board, and from that point we've connected another black ground wire to the ground pin of the MP3 player. If we refer back to the connection point where all the ground points are connected together, later in the build we'll create a common ground connection point using a header pin, and we'll do that later in the build. Also, we've created the connections to pins 4 and 5 to the two 680 ohm resistors, and later we'll add a JST connector to the other ends of those two resistors to be able to connect the anodes of the LEDs. And we've also made a connection point to where pin 2 will be from the Arduino on the shield board, and have connected a 1K ohm resistor, and from that resistor we've made a connection with the blue jumper wire to the RX pin of the MP3 player. We've also made a connection using an orange jumper wire from the pin 3 location on the shield board to the TX pin of the MP3 player. In order to have devices and other items easily be connected and disconnected from our Arduino prototype shield board, we're going to add a few connectors and header pins to it. We'll add a 4-pin straight header pin for connections to the R-, R+, L-, and L+ pins of the DF Player Pro Mini MP3 player module. We'll also add a 2-pin connector socket to make a connection to the Arduino prototype shield board at the two 680 ohm resistors where the LED wiring assembly will connect to that we'll make later in the build. We'll also add a 4-pinned right-angled header pin for common ground connections to the Arduino prototype shield board. We'll start with the 4-pin right-angled header pin for common ground connections to the Arduino prototype shield board. I first connected a 2-pin right-angled header pin, but later decided to add more. So I decided to add a second 2-pinned right-angled header pin to make it 4 pins. So all you need to do is just take a 4-pinned right-angled header pin to add to your board. So let's take a 4-pinned right-angled header pin and place it at column 14, having the pins in line with both ground rows and the rows for the positive 5 volts and the positive 3.3 volts on the Arduino prototype shield board. Make sure that the angled pins are pointing toward the center of the shield board and not towards the power connections we made earlier. We'll end up soldering the 4-pinned right-angled header pin in place. To make things easier to solder and to hold the header pin in place, you can add a piece of tape over the pins to the board to keep the header pins from falling out as you solder them to the underside of the prototype shield board. Next, we need to make the connections from each pin of the 4-pin right-angled header pin to the ground connections we made in steps 1 and 3. We'll solder each pin of the 4-pinned right-angled header pin together. Then solder that whole connection to the black ground wire connections we made in steps 1 and 3 on columns 15 and 16. Be aware that we are only making our connections to ground. Do not solder this header to the positive 5 volt connections. Next, we need to add the 2-pin JST connector socket to the Arduino prototype shield board at column 8, next to and in line with the two 680 ohm resistors we added to the shield board in step 4. We'll then want to solder this 2-pin JST connector socket to the shield board. Do not solder the pins of this connector socket together. Once you've soldered each pin of the 2-pin JST connector socket to the shield board, you'll need to solder each pin to the corresponding 680 ohm resistor lead next to it. This will connect each resistor to its corresponding pin at this connector socket. This connector socket will allow us to connect the 2 red LEDs we added to the OwlBot prototype circuit in part 3 of the project series using a JST XH2Y connector socket we'll set up later in this build. Now we need to take a 4-pin straight header pin and place it at column 4, having the pins be in line with the R-, R+, L-, and L+ pins of the DF Player Pro Mini MP3 player module. Make sure that the pins of the connector socket are placed on column 4 and not on column 3. We don't want this connector socket to be in the through holes that would connect it to pin 13, ground, AREF, and SDA of the Arduino. We'll want to solder this 4-pin straight header pin to the shield board. Do not solder the pins to this header pin together. Once you've soldered each pin of the 4-pin connector socket to the shield board, you need to connect each pin to the corresponding pin next to it from the MP3 player module. Those are the R-, R+, L-, and L+ pins of the DF Player Pro Mini MP3 player module. In step 6, we added a 4-pin straight header pin to the Arduino prototype shield board next to the R-, R+, L-, and L+ pins of the DF Player Pro Mini MP3 player module. Those pins are for the 2 speakers we're using to be able to hear the audio playing from the MP3 player. One right speaker, that's the R- and R+ pins on the MP3 player, and one left speaker, that's the L- and L+ pins on the MP3 player. Now we're going to create a 4-wire connector we'll use to connect from the 4 header pins we just added to the shield board to each wire of the speakers. First, let's cut a 6 to 8 inch length of red 24 gauge stranded wire and strip its ends about 1/8 of an inch. Next, take a DuPont female connector pin and your DuPont crimping tool and crimp the female connector pin onto one of the ends of the red wire you just stripped. Cut another 6 to 8 inch length of red 24 gauge stranded wire. Make sure to keep it the same length as the previous wire and strip its ends about 1/8 of an inch. Take a DuPont female connector pin and your DuPont crimping tool and crimp the female connector pin onto the end of the second red wire you just stripped. Now cut a 6 to 8 inch length of black 24 gauge stranded wire, keeping it the same length as the two previous red wires, and strip its end about 1/8 of an inch. Next, take a DuPont female connector pin and your DuPont crimping tool and crimp the female connector pin onto one of the ends of the black wire you just stripped. Cut another 6 to 8 inch length of black 24 gauge stranded wire, making sure to keep it the same length as the previous wires we just did, and strip its ends about 1/8 of an inch. Take a DuPont female connector pin and your DuPont crimping tool and crimp the female connector pin onto the end of the second black wire you just stripped. Now that we have our 4 equal lengths of wire prepped, 2 red ones and 2 black ones, we can now take a 4-terminal DuPont housing connector and place the 4 wires we just prepped into the housing of this connector. To finish up this 4-wire connector, we need to add DuPont female connectors and the housing to the other ends of the wires, just as we did in the previous steps. Before doing so, I added some electrical tape around the 4 wires to keep them straight, flat, and neat as I worked. Once the 4-wire connector was assembled and finished, I added more electrical tape to keep the wires flattened out and to tidy this assembly up a bit. Here you see me getting a little ahead of myself and cutting two 12 to 14 inch lengths of 24 gauge stranded wire. You see me cutting one red and one black wire, but I need two 12 to 14 inch lengths of red wire. Our goal here is to assemble the wire connectors for the LEDs that we're using as the OwlBot's flashing red LED eyes we set up back in part 3 of this OwlBot project series. I'll leave links to the blog post and to the video for that part of the series down in the description below. I had somehow forgotten to record making the 2-wire connector we need for connecting to the PCB shield board at the 2-pin JST connector socket we soldered to the board back in step 6, which is also to connect to the anodes of the LEDs. It's a shorter connector made up of two smaller lengths of black wire, about 6 to 8 inches. So if you take a look at the images within the orange circle, you can see the white JST connector on the left. That's the XH-2Y housing connector, and the two XH female pins on the right. What you would do is you'd take your two smaller lengths of black wire, each about 6 to 8 inches in length. You would take your crimping tool and crimp an XH female pin connector at the ends of both of the two black wires, just on one end of each black wire. And then you would take those crimped ends with the XH female pins on both of those black wires and insert those into the white JST connector housing that you see in the image on the left in the orange circle. And then as you can see in red, you can see what's called the JST SYP-2Y connector housing. And you'd take a couple of SYP female pins, crimp them on the other ends of the two black smaller wires, the 6 to 8 inch lengths of wire, and then you would insert both ends of those black wires into that red SYP connector housing. And that would make up the smaller wire connector that goes from the 2-pin JST connector socket that's on the shield board, and then the other end of the two small black wires has the SYP connector. And what we'll eventually do is add an SYP connector to the ends of the two longer red wires we started out with. So the connector that you see in this image here will insert into the SYP female connector that's at the ends of the two longer black wires. But you'll see how this works later in the video, and I've left the instructions on how to create these wire connector assemblies for part 8 on our blog post on the website, and I'll leave the link for the instructions for this entire video, this part 6 of the OwlBot project, section 1, down in the description below. Okay, so at this point I've cut a couple 12 to 14 inch lengths of red 24 gauge stranded wire and have stripped both of their ends about 1/8 of an inch. Okay, what you're looking at here is an SYP-2A connector housing, and we're going to use this as one of the connectors on the ends of the two long red wires we just cut, and it's to connect with the SYP-2Y connector housing that we used at the end of the two smaller black wires that we created to connect to the JST connector that we added to the Arduino prototype shield board from before. Now we need to take an SYP male connector pin and a crimping tool and crimp the male pin onto one of the ends of one of the long red wires we just cut and stripped. We're going to want to do this for both of the long red wires. Now that we've added the SYP male connector pins to the ends of both of our long red wires that we cut earlier, we can now grab our SYP 2A connector housing that can fit 2 pins so that we can take the ends of the 2 red wires we just prepped with SYP male connector pins and place the pins into the connector housing all the way until they are securely in. Now that we have one end of both red wires connected to an SYP2A connector housing, we can now move on to soldering the other ends of the red wires to the anodes of the LEDs. We are still working with our 2 long red wires here. Tin the stripped ends of the red wires that have not been connected to anything yet. Next, tin the anodes of the 2 LEDs we are using from part 3 of the OwlBot project series. Take one red wire end and solder it to the anode of one of the LEDs. I'll be adding heat shrink tubing to all my connections, so be sure to add a piece of heat shrink tubing over your wire before you start making any solder connections. That way, once you're done soldering, you can place your heat shrink tubing at your connection and then add heat to it to protect that soldered connection. Then take the other red wire and solder its end to the anode of the second LED. Now that we have the anodes of the LEDs connected to our long red wires with the SYP2A connector at their ends, we now need to make connections to the cathodes of the LEDs so that we may use a DuPont connector to connect them to the common ground header pins we soldered to our Arduino prototype shield board back in step 6. Cut an 18 to 20 inch length of black 24 gauge stranded wire and strip its ends about 1/8 of an inch. We'll need 2 lengths of wire total, so go ahead and cut yourself another and strip its ends as well. Next, take a DuPont female connector pin and your DuPont crimping tool and crimp the female connector pin onto one of the ends of one of the long black wires you just cut and stripped. Now take your other long black wire and another DuPont female connector pin and crimp the female pin onto the end of the second long black wire. The next thing to do is to get a DuPont housing connector that can fit 2 pins so that we can take the ends of the 2 black wires we just prepped with DuPont female pins and place the pins into the connector housing all the way until they are securely in. Now that we have one end of both black wires connected to a DuPont connector housing, we can now move on to soldering the other ends of the black wires to the cathodes of the LEDs. We're still working with our 2 long black wires here. Tin the stripped ends of the black wires that have not been connected to anything yet. Next, tin the cathodes of the 2 LEDs we're using. Place a piece of heat shrink tubing over your wires and slide them out of the way. We'll use them to protect the soldered connections. Take one black wire end and solder it to the cathode of one of the LEDs. Take the other black wire and solder its end on the cathode of the second LED. After you've soldered the black wires to the cathodes of the LEDs, you can now slide the heat shrink tubing up to those soldered connections and then heat the heat shrink tubes to give a nice secure covering over these soldered connections. So you can see here that we have our long red and black wires soldered to the LEDs. This is the DuPont connector end of the two long black wires. This end will get connected to the common ground header pins we established on the Arduino prototype shield board earlier. That section is shown here in the red circle of the image of the diagram. The other ends of these black wires are connected to the cathodes of the LEDs. This end is the SYP connector we added to the ends of our two long red wires. Their other ends are connected to the anodes of the LEDs. As you can see in the image of the diagram, I've circled in red where this connection will be made on the board, next to the two 680 ohm resistors we added to the shield board. This connection is at the labeled points A and B. I've made a pink box around the LEDs in the diagram showing their connections as they should be. For this section of part 6 of the series, we've begun the process of creating a more permanent fixture for the OwlBot to have all its electronic organs soldered in one place. We began the process of transferring some components from the breadboard to the PCB. We've done some soldering and we've made some of our own connectors. We've done a lot, but there's a lot more to do. Transferring everything over from the breadboard to the PCB takes a lot of time and work, and putting it all in one video would make working on it very cumbersome. So, part 6 of this series has been divided into its own sections to alleviate the headache of working on all of this in one go. This was section 1. Next, we'll have section 2, and in section 2, we'll continue our process of creating our own wire connectors and move on to working on making connections for the speakers for the MP3 player and the connections for the peer sensor. We should have all the electronics working and ready to go after that, ready for testing and to finally be placed inside our owl figure. We may finally have a body for the OwlBot. Thank you for participating and thanks for watching. Until next time, keep at it and stay motivated.